Welcome back, everybody. We're going to be talking about linear measure and then more specifically distance and midpoints. So as we get started, I want to talk about a few important things and then we'll actually get into calculating. The first thing is labels. When we're talking about segments or lines or things like that, we really want to make sure that we're labeling things correctly. So in this case, when we're talking about segments and segment lengths, there's two different ways you can label them. The first way is when you're actually talking about the segment itself. So I might be naming a segment, I might be talking about its location. In that case, I would use the segment symbol and then I'd put the two letters RT. That's what we did in the first section. So that's just read segment RT. However, if I'm just referring to the measurement of a segment, maybe I would say that the length of RT is 5 inches or the length of RT was 20 yards. Then in that case, you do not use the symbol above, you just use the letters here. Okay, so the without, this is referring to the measure. That's very important. So if you're not referring to the measure, you need to make sure you label it with the segment above. Okay? The other thing that's very important is the difference between equal and congruent. They're related, okay, but equal is just referring to the measurements. And so I might say that one segment is equal to another, which means that they're both the same length. Congruent refers to the same size and shape. Okay, so in an example, I might give you a rectangle where you've got, this is a length of 2 and this is a length of 4, but then I've got another rectangle where it's still a length of 2 here maybe, but this time this is a length of 10. So obviously these are not congruent, and that's because although they are both rectangles, they don't have the same size. So they have equal side lengths. Two of the sides are 2 inches or 2 centimeters, whatever, but the other sides are not, which would automatically make them not congruent. So just be aware that equal refers to the measurement, congruent refers to the actual size and shape, so that's very important. And the congruent symbol, in case you haven't seen it before, it looks like an equal sign, except congruent is an equal and then it has this right above it. Okay, so equals, congruent. Make sure you know the difference between those symbols. Now we're going to go ahead and actually calculate measures and find distance. This first example is really short. It's just to show you kind of some placement. When it says that a point is between two other points, that doesn't necessarily mean it's in the middle. It could be in the middle, but notice that I have point B that's actually a little bit closer to point C. So if it says B is between A and C, just put the point somewhere if it's not already drawn for you. In this case, they're looking for the length of AB. And you notice here that we've got it labeled that the whole segment is 15 and B to C is 3. So all you have to do is subtract, and then you get that the length of AB is equal to 12, and you'd be done. Okay, so this is knowing that one part of a segment plus another part of the segment can equal the total. So the same concept is going to be used in number 2. It's just already got equations and things in place. They want you to find the value of A, and they also want you to find the length of xy. So to do this, we're going to go ahead and set up our equation, and you have to understand which parts get added together. So remember, these smaller parts, that's xy and yz, I'm going to add those together and equal them to the total. That's xz. And then I can just go ahead and plug in my equations. 3a plus 14 is equal to 5a minus 4, oops. And then go ahead and solve. Subtracting 3a to the other side, we get 14 is equal to 2a minus 4. Now I can add 4 over, and I get 18 is equal to 2a, and then divide by 2, we find that a is equal to 9. Now the one thing I want to make sure to remind you guys is that there might be multiple parts to a question. So here we found a, but remember in the directions it said also find xy, and that means that we're going to have to plug this a value back in to the equation for xy. So it said xy is 3a, so I'm just going to take 3 times 9, and that means that xy's length is 27. So just make sure you read the directions carefully, make sure you answer all parts, that way we're not accidentally making some mistakes as we go through the sections. Finally, we're going to get to distance. Distance should be somewhat familiar to you. There's basically 3 ways you can do distance. You can use a number line, which is very basic, you can use distance formula, or you could do Pythagorean theorem. On a number line, that would simply be me just counting between 2 points that would be plotted. For example, maybe I wanted to find the distance from point A to point C. So all I'm going to do is start at the point A and then count 1, 2, 3, 4, 5. So my distance is 5. Very simple. You guys have done that before. Midpoint, you could do the same thing. Figure out how far it is and then divide it by 2. Okay. Now, what you will see more commonly is when I give you 2 points. And in this case, you can either use distance formula or Pythagorean theorem. Pythagorean theorem you're more comfortable with, probably, but it usually takes a little bit more work just to set it up. So if I start with Pythagorean theorem, I'm going to go ahead and plot these points. So -4, -6. So there's C. And then 5, -1. So 1, 2, 3, 4, 5. And the easiest way to use Pythagorean theorem on a graph is to count and make a right triangle. So I'm going to just draw this dotted line over and up. And remember, we're looking for the distance from C to D, so that solid line or the hypotenuse. And all I have to do is label my lengths, and I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a length of 9. And then from this right angle, we can count up 1, 2, 3, 4, 5. And now we could use Pythagorean theorem, which is c squared equals a squared plus b squared. And remember, we don't know the hypotenuse. My legs are 9, so 9 squared, and 5 squared. And I'd get c squared is equal to 81 plus 25, which is going to get us c squared is equal to 106. And remember, you want to always square root at the end, so we get the square root of 106 would be our length. The distance formula, which I'll go ahead and write here, definitely write this in your notes. This will get you the same exact answer. It's just a slightly different approach. You don't need a picture for it, so it's just up to you. Just make sure you know how to do both methods. This one, we'd label our points x1, y1, x2, y2, and then you just plug into the formula. So that would look like this. 5 minus -4 squared plus -1 minus -6 squared. Notice I wrote the negatives. If they have an extra negative, make sure you write it separately. And that's usually so you don't make mistakes with your signs, because we know that 2 negatives will become a positive. So this is really going to turn into 5 plus 4, which is 9, and then squared. And then if I have 2 negatives here, they're going to become positive. So that means I'm going to have -1 plus 6, which is a positive 5. Squared. And then what you notice is it's the same as what we did just a minute ago. 81 plus 25, and you get the square root of 106. Okay, so same answer, different method. I want you to make sure you know how to do both, but it's kind of personal preference. If I don't tell you which one you have to use, you can use whichever method you prefer. Okay? So that's it on the distance. The next video is going to be about midpoint.